Chapter 10, Wave Theory of Light or Wave Optics, Wavefront. This is the first concept. This is, I will say, this is a concept, one kind of drawing technique to understand the Huygens theory, wave theory of light. So till now you just understand that we are learning a one kind of drawing, one kind of technique, one kind of drawing technique to understand the motion of light, so that we can explain those phenomena which are very complex. Now Huygens assumed that in his time he assumed that there was a very thin medium which is present throughout the space. This medium was ether. So he considered that light used to travel through this medium, which is not wrong. Today we know that light is an electromagnetic wave which do not require any medium for its propagation. However, Huygens assumed, so you have to understand this from now on, and you don't forget this. Throughout this chapter you must remember that Huygens assumption was that light needed a medium for its propagation, and this medium was called ether. So with this, let us come to some introduction to some topic before we can go to much more further topic. Let us get into some kind of introduction to some most important word, that is called wavefront. What is this wavefront? As the definition says, is that the locus of points over surface having same phase of vibrations is called wavefront. The locus means a group of points. So group of points over a surface having same phase of vibration is called a wavefront. So to understand this, imagine that you take a this is the floor, this is the surface of water, and you drop a stone. As you drop a stone, what will happen? Ripples will be produced. So as the ripples are produced, then all these particles, they are going to vibrate. Let us take a look into an animation, then you are going to understand what do I mean. So look at this picture here, animation here. So let me play this. So if I play, what do you see? Can you see green circle? Look at this green circle. All the particles of the medium on this green circle, they are vibrating at the same phase. So if I rotate it, you can see, and let me play the animation. At the time, along with in time, all the particles are vibrating, they are in the same phase, they are expanding, they are growing, but all the particles on the green circle, they are expanding at the same rate. There is no difference, no lagging. So we will call this green circle as a wavefront. As this one is in the form of a circle, we will call it as a circular wavefront. Again you can understand, I will highlight it. So what is a wavefront? The wavefront is what? Is a locus of all, is a locus of or group of points which are vibrating at the same phase, or whose motions are in the same, are identical. In this case you can see their motion are identical on this green circle. So they are expanding on there, they are expanding all together they are expanding, hence such a thing is called as wavefront. Now let us get back to the other. So now we can classify wavefronts into three main categories. One is the spherical wavefront. So what is a spherical wavefront? So when based on the source, we will consider these as three: spherical wavefront, cylindrical wavefront, and plane wavefront. So what is a spherical wavefront? Now imagine that as we are learning with this form of disturbance, now this disturbance by the word the source of disturbance in case of light will be the light source. Although we are learning the concept, we are learning the maths, we are learning the diagramming technique in the form of vibrations, light is also one kind of vibration. So light source will be the cause of the vibration, which is light. This is what we mean. So imagine this is a point source S here, which will, in case of spherical wavefront, it will give rise to spheres. Let me draw lines. So if I draw a line like this, at the center lies the point source S. So, it will give rise to spherical wavefront, which are in the form of a sphere. So, this disturbance will be traveling uniformly in all direction in the sphere. So, imagine a 3-dimensional sphere which is growing, whose diameter is, whose radius is expanding, just like this circle. Try to play on your mind. It is just a sphere which is gradually increasing. All the points on the surface of the sphere is gradually increasing, slowly is increasing. Such a sphere will be called as spherical wavefront. So, spherical wavefronts are produced by the point source. Spherical wavefronts are produced by point source. So, here is the point source S. So, when a source of disturbance is a point source, waves originating from the point source travel in all direction, and the resulting wavefront will call it as what? Spherical wavefront. Just like we have seen this circle. Now, in case of a spherical wavefront, it will be a sphere which is expanding in 3 dimension in all direction. Okay. So, you can imagine that this is the x, y, z coordinate, and this is the sphere which is growing, which is gradually increasing like this. So, this will be called as spherical wavefront. Let us see what are the next two. Next is the cylindrical wavefront. Now, imagine now when the source of disturbance or the source of light source is a straight linear light source. So, let us say something like this. I will give an example. Let us say this is a board, and here is a very small hole in the form of a rectangle. We will call this as rectangular slit. The small hole in the form of a rectangle, we will call it as slit. Okay, rectangular slit. Now, this will give rise to, when light comes out of this slit, what will give rise? It will give rise to ripples in the form of semicircles like this. After a while, it will grow to this and like this and so on, right. Hence, such a wavefront will be called as cylindrical wavefront. You see, there will be no waves in the top, no waves in the down. So, such a wavefront will be called as cylindrical wavefront. So, cylindrical wavefront generally we show like this way. So, you can see this is the wave, this is the linear source axis, here it is expanding, so this surface S is what it is expanding in space. All the particles, imagine a cylinder, imagine you just consider this diagram, consider this picture. Here is only a circle which is expanding, and in this case it would be what? It will be a plane, which it would be a surface, a cylindrical surface which is expanding gradually. Such a wavefront is called, such a disturbance is called cylindrical disturbance, and in case of light we call this as it will be the cylindrical wavefront caused by a light source. Now, the next one, the last one will be the plane wavefront. In case of plane wavefront, is very simple, is that whatever be, whether it is a cylindrical wavefront or whether it is a spherical wavefront, when the observer is very far away from the source causing this, imagine that this is the beach, sea shore, and this is the beach, and here somewhere this is the ocean, this is the ocean here, and some kind of explosion took place here. As a result, what will happen? It will give rise to a big huge ripples like this over the water surface, which is going to be traveling in all directions, right. This is the ripple of water. As it comes closer and close, what you see, for the observer who is very small and standing here, this big ripple will appear to as a plane, right. So, this is all these things will seem to be this ripple of water will appear to as a wall of water. So these things is nothing but a plane wavefront. So hence plane wavefront will be what? All the particles of the medium on the surface are at same phase of motion or vibration. We will call it as a plane wavefront. So plane wavefront generally we are going to show it like this. So this is the plane, this is the diagram of plane wavefront. These arrows gives these are the rays which gives you the sense of the propagation direction of the plane. Similarly, you could have drawn one more here. You can draw one more like this. This giving you the idea that the wave is propagating in which direction. All the points here, they are all vibrating at the same phase, same motion, same direction of motion, everything same. So such group of points are called, locus of points are called wavefront, and this is a plane wavefront. Let me show you one animation regarding this. You can see a blue line, it is a plane wavefront. All the points on the blue lines, they are vibrating at the same phase. So this is called a plane wavefront. If I look from there, if I look like this, you see it's just a plane, a straight line, right? So this is a concept of plane wavefront. Thank you.